Hi guys, welcome to your lecture on Limacons. So this is our new polar graph. This is for the polar equation that is of the form r is equal to a plus or minus b times cosine or sine of theta. So any polar equation that has that form is going to look like one of these. This might look a little bit daunting because there's 10 of them, but first thing I want to point out is that these two right here are circles. So those aren't Limacons, so we're not going to talk about those today. All right. And then these all correspond with ones above and below. It's just depending on if it's sine or cosine. So if it's cosine, your Limacon is going to be symmetric over the x-axis. And if it's sine, your Limacon is going to be symmetric over the y-axis here. But you'll notice that these are both what we call convex or flattened Limacons. So really you only have to remember 4 different types of shapes and then which axis they're symmetric over. So how do we know what type of shape we have? So first one that we're going to start with is convex Limacon or flattened circle. You can kind of see that shape here. This is when you have your absolute value of a over b is greater than or equal to 2. So in this case our a value is 2, our b value is 1. Since 2 over 1 is equal to 2, we have a convex Limacon. Next one is dimpled Limacon, so that just has this little dent right here. That's when your a over b ratio is between 1 and 2, but not equal to 1 and not equal to 2. Next up, we have our cardioid or our heart shape. This is when our a to b ratio is equal to 1. It's kind of like the dimpled, but just goes down a little bit further, makes a little bit of a heart shape. Next, we have the inner loop or the loop-de-loop. I think that's more fun, so we're going to call it that. That is when your a over b is less than 1. And remember, these are all absolute values. So, and then the last one we don't really care about. This is for any b value. So any b value, just giving you an a equal to 0, will give you a circle. So we don't really care about those today. We care more about these 4. So now you know how to know what kind of shape it is, but the question is, how do you graph it from that? With our petals, we kind of had a nice little flow chart to go through and worked out really well. It's not as easy with these ones, okay? So kind of throwing back to what feels like 8th grade math, you're going to need to make a table that looks something like this. So this one right here is an example of the inner loop or the loop-de-loop one, all right? This one is the same type of graph, so I'm going to skip that one for right now. These will be in the completed notes though, so you can see those. And we're going to go down to a different shape. So this one right here, we have r is equal to 5 plus 4 cosine theta. So first thing, we have cosine, so symmetric over the x-axis. And then for our a over b, we have, which one is a and which one's b? I'm blanking right now. 5 over 4. So 5 over 4 is between 1 and 2. 1 less than or equal to 5 over 4, less than 2. So going back up to our chart up here, since a over b is between 1 and 2, this is a dimpled Limacon. So next thing we want to do is we want to create our chart. So we know, and we're going to go down here for it, we know that r is equal to 5 plus 4 cosine of theta. And we want to find out what r is for different values of theta. So again, looking up here, it says we're just going to graph these for 0 less than or equal to theta less than or equal to 2 pi. So we're just going around the circle once. So let's pick easy values for theta, all right, because we're taking the cosine of these theta values. So what if theta is equal to 0? Pi over 2, pi 3 pi over 2, and then 2 pi. Let's make our lives easy, right? So Next up, we're just going to plug these values in for our cosine. So we have r is equal to 5 plus 4, and then we take cosine of 0. The cosine of 0 is 1. So 5 plus 16 is equal to 21. Or no, I'm sorry, that should be a 1, not a 4. Wow, okay, Miss Strauss. Times 4, this is 9. Okay, there we go. Now, we do the same thing, but with pi over 2. 5 plus 4, the cosine of pi over 2 is 0, so we just get 5. Next, r is equal to 5 plus 4, cosine of pi is negative 1, so 5 plus negative 4 is just 1. R is equal to 5 plus 4 times the cosine of 3 pi over 2, which again is 0. So we get 5. And then last but not least, r is equal to 5 plus 4 times cosine of 2 pi, again, is 1. So we have 9 again. All right, so now we go about graphing. And remember, these points are just our axes points. So we're starting here on this line here, where theta is equal to 0. And we're going to say that these rings each represent a value of 2. Okay, so 2, 4, 6, 8, 10. So when theta is equal to 0, when we're on the x-axis, our radius is equal to 9, or the distance from our center is 9. When theta is equal to pi over 2, or positive y-axis, our radius is equal to 5. So that's between these circles here. When theta is equal to pi, our radius, our distance from our center, is 1. So that's going to be right in here. When theta is equal to 3 pi over 2, our negative y-axis, our radius is equal to 5. And then back up at 2 pi, we're at 9 again. So graphing this out, you guys know that my art skills are subpar. So my shaky hand here. We have our dimpled limacon. So that is that one. I want you guys to take a minute, pause the video, and give this one a try. All right, welcome back. Next we have this problem right here. So we have a sine, so this one is going to be symmetric over the y-axis instead of the x-axis. First thing we should do is find a over b. So a over b in this case, 5 over 5. So since it's 5 over 5, that gives us that a over b is equal to 1. And then before I start going, that's what I thought, it is our heart shape. So next thing, we make our table. R is equal to 5 plus 5 sine theta. And we want to do this for our different theta values. So again, we always pick the easiest values of theta that we possibly can. So you saw in the last example, we did these 5, and it gave us a fairly good outline, again, except for my horrible handwriting. So this one here, when theta is equal to 0, we have 5 plus 5 times sine of 0, which is equal to 0. So this one is just 5. Next up, 5 plus 5 times sine of pi over 2, which is positive 1. So that's equal to 10. Next up, 5 plus 5 times sine of pi, which is 0, equal to 5 again. 5 plus 5 times the sine of 3 pi over 2, which is negative 1. So this is equal to 0. And then again, we're back at 2 pi. 5 plus 5 times 0 is equal to 5. Again, we're going to pretend that these lines each have a distance or a marking of 2, 2, 4, 6, 8, 10. So, starting at theta equals 0. When theta equals 0, our radius is equal to 5, so we're between these two right here. When theta is equal to pi over 2, so we're on the positive y-axis, our distance from the center is 10, up there. Then we go to the negative x-axis. When theta is equal to pi, we're back at 5, 2, 4, 5 right here. Then when we are at 3 pi over 2, our negative y-axis, our distance from the center is 0, so we're in here. And then when we're here again, we are back at 0. So since we know that this has a heart shape, oh my goodness, that was a horrible start. We can draw this in, and it will look something like this. You know, that's really ugly. Wow, okay. So we have 5 plus 5 sine theta, and then you can go into Desmos here. R is equal to 5 plus 5 sine of theta, and it will give you a very similar graph. That's just a lot prettier than mine. So you can always check your answers on Desmos. On tests, I'm not going to be looking for art skills because obviously I don't have any. So not fair for me to judge you guys on that. As long as you have the heart shape and it's symmetric above the y-axis, you're good to go. So there will be a few more of these. You don't have to do all of these in the packet. I'll be posting more with the completed notes, but since we have other lectures and other shapes to go through today, I'm not going to go through any more examples.